Okay, yes, to the Professor, Dr. Dolphy Gilpin, and we're looking at now radium, the most radioactive element, natural element on the Earth. You have some other radioactive one there too. I think technetium is one, but that's not, that's synthetically synthesized. It's not natural, but radium is naturally found. And so here we look at this radium here, and if you notice in other view, this was looking like a tree, so I've made it look like its real number, which was 88. So the radium is 88, but in other viewing, it looks like 38 because, the curve wasn't put in there. So the atomic number radium, 88, and atomic weight of 226 for its most stable isotope. And it's the most radioactive natural element on the face of the earth. There are others that surpasses its radioactivity, but they are not natural. They are synthesized. Okay, so that's the radium. And let's now look at it. I'm going to take a series of steps here with the radium. More lengthy production here. So this is the radium, and this is the radon. We are finished with radon now, so we could put it away. Though it will turn up every now and then in reflection. Radium 88, 226, and let's look at its electronic configuration here. Radium Re, 226. It has electronic shell configuration 2, 8, 18, 32, 18, 8, and 2. That is the shell. It's the shell aligned. What is electronic configuration now is Rn 7s2, which is Rn is radon 7s2. And some of the isotopes, let's look at some of the weights on the isotope here. We have radium 226, radium 228, radium 223. And I'm certain there are other radium there too. I think you'll have about 24 others, but these are the ones that are focused upon. Radium 226, radium 223, radium 228. All right. So it's a group 2 alkaline earth metal, period 6. And radium was discovered by Marie Curie and Pierre Curie, like two husband and wife, or brothers and sisters. I don't know, it look like husband and wife there. Okay, Marie Curie and Pierre Curie in 1898 it was detected, but it was isolated in 1902 and again in 1910. That was when they isolated. I think one time they isolated from polonium. I don't know the time. I don't know what it was, but there's two separate isolations in 1902 and 1910. But it was detected earlier in 1898. And as we said, it's the most radioactive natural element, 1,000,000 times more radioactive than uranium, and about 200 times more reactive than plutonium. It is so radioactive that it gives off a pale blue glow. Now, radium is silvery, it's lustrous, soft, and intensively radioactive. It readily reacts with air. Yes, it's very reactive as compared with radon, uh, which is an inert gas. It, it readily reacts with air, forming uh, with air. It's going to form radium oxide, RaO. That is Ra plus O2 give you RaO, and then to balance it, I guess you'd have to have 2 Ra and then 2 RaO. Because O2 is already 2. So you get two twos right out there. Okay, so that is the reaction with air, and it readily does that. And when it does that now, it moves from the silver white color to a black color. Now in water, this radium will react with water to form radium hydroxide and hydrogen. And you know that's the property and characteristic of reaction of the alkaline earth metal like magnesium and calcium. They will react with water, liberating hydrogen, you know. But as you know, since radium is way down in that group, it will be more reactive even than barium and strontium, calcium and magnesium. It will be more reactive there. So it will form more vigorous reaction with water. So that's it. It corrodes, luminescent corrodes in water, forming radium hydroxide and hydrogen. Now, radium 2 plus ions are colorless, and Ra2 plus, oxidation state of 2 plus, so that Ra plus water, Ra plus H2O will give you RaOH2 plus hydrogen, which is the radium hydroxide plus hydrogen, just like the magnesium reaction with water and calcium and barium and now the radium. But radium would be more reactive because elements further down in the group are more reactive than elements at the top of the group. It also reacts vigorously with hydrochloric acid, so that radium plus hydrochloric acid will give you radium 2 chloride or radium chloride. Radium rapidly reacts with the nitrogen also when exposed to air, and the radium nitride. That should be N2, Ra2, Ra3N2, something like that. Also react with bromine to give you radium bromide, and radium and beryllium. Were once used as portable source of neutron. That is the radium plus the beryllium. Were once used as a portable source of neutrons. No radium used in medicine, and I guess those are in the past 19th century and even in the 20th century, 20th century. Most of these uses are now reduced in the 21st century here. These are the uses. Radium is used as in medicine to produce radon gas. So radium Ra is used to produce the radon gas Rn, and we have already talked about the uses of radium in treating malignant tumors and all of that. And for the treatment of cancer treatment, yeah, and we specify even the sort of cancer there. Sometimes it's in prostate cancer. We'll come up with that, but lung cancer as well. In the 19th century, radium was used as in toothpaste and in ear creams and also in food. But a lot of these uses in these modern time have been reduced or phased out. Now, it has been estimated that each square kilometer of the Earth's surface, to a depth of about 40 cm, contain about 1 kilogram of radium. So that is it's naturally occurring, and we're giving you the sort of volumetric mass sort of statistically on its occurrence in the Earth's surface. It's estimated that each square kilometer of the Earth's surface, to a depth of 40 centimeter. 40 centimeter, you could estimate that, like if you say 40 centimeter, 3 to 40 centimeter, or say 40 inches, that would be nearly 3 feet or so. So we're talking about that, going down to that depth there. Estimate approximately contain 1 gram of radium. Now this radium in the 20th century, the use, although it's reduced now, was extracted from uranium ores for use in luminous dials. Luminous dials in the clock dials and the clock hand, and in medical treatment. And the amount of radium in uranium ore was estimated to be about 150 to 350 milligram per ton. And the source of it was from Zeri and Canada. The source of these ore that has the 150 to 350 milligram per ton in terms of the richness of this radium in the uranium. Now, humans release radium in the environment by burning coals and other fuels. When they burn coals and other, they release radium in the environment. And radium levels in water, in underground water, if these underground wells, deep wells, are found near, say, radioactive site, dump site, then there will be a lot of more radium in the water. So you have the burning of fuels like coal and other fuels, and you have groundwater that is located near radioactive sites, dump sites. All right, so we'll take a break here, and then we'll return with some more radium.